This is Radio TV Phono Nut, and here's another example of a curtain burner series string radio from about 1933, only this one's in a bit better cosmetic shape than the last one we featured. This is a metal cased one. I'm not sure if it's been repainted or not, but if it's been repainted, they did a pretty good job. This is a General Electric model M-40, which is the same thing as an RCA model 102. At that time, GE and RCA sets were the same, and I think Westinghouse too. Here's the back, which is metal too, and the 3-wire resistance line cord, as you can tell, is in raunchy shape and will need to be replaced. This is the antenna wire. Now, let's look at the schematic. Like the last curtain burner we worked on, this one's a 4-tube TRF set. We have a type 78 as an RF amplifier, a type 77 as our detector, a type 38 is our audio output, and a type 37 is a rectifier. Now the 37 is a triode, and they have it wired as a diode and using it as a half-wave rectifier. The speaker looks to be the magnetic variety, which means it has a high resistance voice coil, and there's no need for an output transformer. The speaker voice coil is directly in the plate circuit of the audio output tube. Now, this particular set uses tube filaments that are, each tube is 6.3 volts at 300 milliamps. And here's the resistance portion of the line cord, 315 ohms. I did the Ohm's law calculations and came out with the same reading. And this resistor needs to dissipate roughly 28 watts. So we'd want to put a 50-watt resistor in there. Or what we could do, since these are all 6.3 volt tube filaments, and if room permits under the chassis or on the chassis, I could rewire the filament string to be in parallel and put a 6.3 volt filament transformer in there. But if we have to go with a resistor, if room permits, the nice thing about it, this case and chassis is all metal, so that'll make one giant heat sink. Or we might go with a capacitive dropper. We'll just have to see. Here we are with the back cover removed, and there's some fiber board or something in here between the chassis and the metal cabinet, most likely because this is a hot chassis set and they're using this fiber board or cardboard or whatever it is to insulate the cabinet from the chassis. Here we are with the chassis removed, and looking at the underside, it looks to be mostly original. This is our filter capacitor here that's loose. I think somebody's been messing with that. What is this? A very old Cornell Dubilier capacitor with a shop sticker on it that says Radio Electric Company, 487 Campbell Avenue, West Haven, Connecticut. And here are a couple more filters on the top side that look to be replacements. All this one says is positive on it, and it was originally a dual section. Someone cut one of the sections loose, so this could be an original. And this one back here, and this one is a dual 5 microfarad. So far the only evidence of repair I can see is that these filters were replaced many decades ago, probably 70-75 years ago. Here's our speaker, made by Best Manufacturing Company, and it's rather primitive looking, and the cone looks to be in good shape. And looking at the tubes, our type 37 rectifier looks to be an RCA Cunningham Radiotron original, as does our type 38 audio output tube, and our types 77 and 78 also look to be RCA originals. So this thing appears to have an original set of tubes in it. Looking at the schematic, it looks rather straightforward, and no common positive filter capacitors and no goofy bias circuit. They indeed have a 0.05 microfarad isolation capacitor between circuit ground and the chassis, so that helps a little bit as far as alleviating the lethal shock hazard from a hot chassis. Of course, you can still get a shock, but that capacitor should limit the current flow to a non-lethal level. Of course, after almost 90 years, that capacitor is surely very leaky by now. Reading across the power plug, I'm not getting any continuity, which I didn't figure I would. And it also looks like the power switch is open, but a lot of times these can be taken apart and cleaned and persuaded to work again. I certainly hope that's the case with this one. Okay, the resistance element is open, no surprise there. However, I am getting continuity across the series string tube filaments, so that means at least our tube filaments are intact. Okay, I'm checking continuity of all of our coils and transformers, and I'm starting with the second RF transformer. It looks to be okay continuity-wise, so that leaves the antenna coil, the filter choke, and the speaker voice coil. And if all that's good, then we should be pretty smooth sailing here. Okay, everything reads continuity, and the speaker even gives us a click whenever we place our own meter leads across it. So hopefully this one will be fairly routine. Okay, here's the deal with the electrolytic capacitors. The two round ones, I believe, are original to the radio. This one here does not have a value printed on it, but the schematic says it's a dual 4 microfarad, and one section of it was snipped off and replaced by this square thing. This one here is a dual 5 at 50 volts, which is the cathode bypass capacitor for both the audio output tube and the detector tube. I don't know if this 113 is a date code or a RMA number, but if it is, it's the 13th week of 1931. And this one has 123, which would be the 23rd week of 1931. And 66197-6. And 66197-7, whatever that means. And the replacement rectangular one is reading 3 microfarads, and it's a 4 microfarad, so that one's still kind of good. And the original equipment dual 4 microfarad is wide open, as you can see, and this cathode bypass is wide open, reads like 0.2 microfarads for each section. Just to give you an idea, this is a dual 5 microfarad at 50 volts. Let's look at a 2020 version of 2 5 microfarads at 50 volts. Yeah, 2 4.7s, 1 dual 5. I could fit a year's supply of modern day 4.7s inside of the case of that old dual 5 capacitor. And 2 new 4.7s versus a dual 4.7 older one. Yeah, they have gotten a lot smaller over the years. Here's our 2 filter capacitors in place, 2 4.7s at 200 volts, and how convenient. A circuit ground point on this RF coil is a perfect tie point. We can go connect our positive straight to the filter choke. And we have 2 other paper capacitors at ground here. This one is the isolation cap between the chassis and circuit ground. And this one here is a screen grid bypass cap on the first RF tube. And I was very careful with this coil terminal. I don't want to stress it or cause it to any damage. So I made me a little connector out of a piece of bus wire, so instead of attaching directly to the coil terminal, we'll attach these grounds for these two capacitors right here in this little hook that I made, and solder it up. It'll be just fine. Well, today's smaller modern parts allow me to make things look neater and save a lot of space. For example, we have this 0.004 capacitor. No, I haven't connected the other end yet. It connects between the plate and the screen grid of the audio output tube. Now, the screen grid also runs over here, the lead from the screen grid also runs over here to the RF amplifier tube. And they had the big honking capacitor, one end connected to the plate and ran over here and connected to the RF amplifier tube because the part was physically too big to put it between the actual plate and screen terminals on the audio output tube. So with today's smaller parts, we can do that. And here are the two electrolytics that I've already replaced, and here's another capacitor that I've replaced. Need to clean this up a little bit. These terminals are kind of hard to work with, but we got everything soldered. There was a 350K resistor here. It comes from the screen supply from the output tube over here to this RF amp tube, a drop-in resistor. And it was up about 100,000 K higher than it should have been. The original was 350K, which is non-standard, so I put a 330K in there. And then we ought to be good to go with that. Here's the power cord disconnected, and it's rather interesting how they have the strain relief done on this. They just have a portion of the outer jacket coming back here and tied to the back of the chassis, so if you pull on it, this will keep you from pulling the cord out of the radio. And this is a better quality cord than the one that was on the Traveler. On this one, the inner wiring has cloth insulation, whereas the one on the Traveler had rubber insulation. The power cord itself is okay, but as far as continuity goes, but the resistance element, this asbestos covered white wire here, is burned open, which most all of them are. Okay, we have our power cord installed with it knotted so it can't be pulled out of the chassis. Had to do a couple of unconventional things to mount a couple of these capacitors. This across the line capacitor, it's fine right here at the tube socket, but to circuit ground is way over here. So I had to solder a piece of bus wire to our existing capacitor lead and run some spaghetti tubing over it to where we could connect it over here. Same goes for this audio output tube cathode bypass capacitor. I had to attach a piece of bus wire to it and run it way over here to our ground point. Now I'm about to the point of stopping the recap. I want to find I think I have a 24-volt transformer that I can power these tube filaments with for right now, and I just want to see where we are with this. Here's a transformer that I removed from a junk school record player. Unloaded, it puts out 29 volts, and that's close enough for government work, so we can temporarily install this, and if it's still a little bit overvolted, we can compensate for it with the Variac. Okay, I decided to go ahead and finish the capacitors before I attempt to come up with a way to power the filaments in this thing. And I had to do a couple of them in a way I really don't like to do it, but when the leads of the new capacitors are simply nowhere near long enough, then I just simply cut off the old capacitor and attach the new capacitors to the leads that formerly attached to the old capacitor. And in this case, the old capacitor leads are way more stout than the little thin bus wire that I've got, so it'd be just better to do it this way. And there's nothing here for this to short out to, and this one here is stout enough, it's not going to short out to anything, so we got that done. And then we replaced this antenna isolation capacitor. Once again, I had to use heat shrink and spaghetti sleeving to insulate the leads where the capacitor wouldn't short out to anything. Now we have to tend to this rheostat that's in the antenna circuit. Just like the one in the Traveler, it's very erratic when you tune it, and the off-on switch is not making contact. Off-on switch is no big deal. I can always just jump it out and unplug the radio and plug it in whenever I want to turn it off and on, which is probably what you should do with these older radios anyway, because when you use the original off-on switch that may be part of a control that's very hard to get these days, every time you use it, you're just putting that much wear and tear on it, and one day it could very well break on you. So, and this one feels like there's something in the control blocking its travel, so we need to try to take this apart and open it up and see what's going on with it. And here it is. This one actually cooperated and came right on out, unlike the one in the Traveler. So now we have to get a small screwdriver and gently pry up these tabs, hope they don't break, and then we can separate this and see what we can do with it. This thing's not wanting to separate, and I don't want to pry on it too much because I don't want to break this phenolic, but I managed to get a hole big enough that I can get my squirt nozzle down in there and hose it down with contact cleaner and see if that'll help it out any. Well, we got the off-on switch working, and the resistance is a lot less erratic when I turn the pot now, but we still have this rough spot. I'm wondering if possibly this pot or rheostat didn't have a mechanical stop to keep it from going past a certain point, and somebody forced it and broke it. And if they did, they just did, because it's just going to have to be that way. Now I'm going through the resistors. This one here was a 1 meg. It was reading 1.7 meg. And you can see how much smaller they've gotten over the years. And I don't know why, but all these resistors have this black stuff over them that I had to physically cut off in order to remove them from the resistor. I don't know whether that was RCA or GE's way of trying to keep you from seeing the value of them or what. I know the capacitors all have some kind of numerical code on them that I can't make out. The only way I know what value they were was by the schematic. And you read these older resistors, body, end, dot, bed is how you can remember that. So the outer body is green, that's 5. Black is 0, the end. And yellow is times 10,000. So 50 times 10,000, that gives us 500K. Okay, I'm on to something. I found a bunch of 1 microfarad film capacitors in my junk, so I just put enough of them together to come up with 6 microfarads to put in place of the dropping resistor. And we have close to the right filament voltage across the tube string. And it's working somewhat. I have the volume all the way up, and like I said, that rheostat there's something the matter with it anyway.
Mississippi, 93.1 FM, 1390 AM, W226 PM. A land of deliciousness, because it's next, the fun starts here. Portions of the following program were pre-recorded. From the Veldins Automotive and Tire Studio, Veldins Automotive and Tires, your diesel specialist. This is News Radio 1200 WOAI, San Antonio, an iHeart radio station. Well, one strike. Let's pause. Or for the purpose of selling.
There's Well, that's a pretty good start. So I have 4 1s and a 2 in parallel to give us 6. And at least that was good enough to test this to see if it was going to work. And it does. There's still things that need to be done to it, but we know that we're well on the way now. Okay, we're about done with this.
Higher. The Dow up about 980.
And I'll show you what's taking place. If you notice, I have a terminal strip soldered to the rear of the chassis, and on that terminal strip we have a 6.8 microfarad 400 volt capacitor in parallel with a 100 k ohm 2 watt resistor, and that gets our voltage, tube voltage, close to what we need it to be. When we add the 4 6.3 volt filaments together, that gives us 25.2 volts. And I'm checking the radio over a wide range of operating voltages. Right now I'm running it in 100 volts line input, and that gives us 16.6 volts on the filaments across the filament string. Now, these tubes, as long as you don't overvolt them or severely undervolt the filaments, they really don't care how much voltage is on them, because the only purpose for the filaments, or heaters if you prefer, is to heat the cathode of the tubes to the point where they'll emit electrons. And as long as you put enough voltage on those filaments to do that, then everything's happy. And the purpose for the 100 k ohm resistor across the capacitor is just as a safety precaution to help discharge the capacitor when you turn the set off. Alright, I'm going to crank our input back up, get it back up to about 24 volts.
Metabolic diabetes, high LDL cholesterol, having a heart attack, and even damaging your internal organs like having fatty liver. Did it get everybody's attention? The pharmacists at 30's Labs recommend taking Mitoblast 2 once or twice a day. I take 2
and it got a little louder as I raised the voltage up, which I expected, because not only will raising line voltage cause the filament voltage to go up, it'll cause the plate voltage to go up a bit, but that just proves that this radio will operate satisfactorily from 100 volts to 120 volts,
nutrients work by triggering the same cellular pathways as exercise. That's why I refer to it as my exercise in a bottle. And it works well when combined.
Let's see what we're running as AC input at 26 volts on the filament.
30labsrx.com.
We're running 127 volts AC input, so yeah, this radio will pretty much operate satisfactorily over the range of AC line input voltage which you're most likely to encounter. Alright, at 120 volts line input, we have 23 volts, 23.8 volts across the filament string, so that's good.
It does not have
I think we can put this thing back together and call it a day. Now, the main advantage to this capacitive dropper, as I've already mentioned, is no heat whatsoever, and that's a plus. The main disadvantage is this radio is no longer an AC-DC set. You must operate it on 100 to 120 volts, 60 cycles only. Any other frequency is going to alter the voltage placed across the filament string, but since pretty much in today's world in the United States our voltage and frequency is pretty much standardized, then it should be no problem. Alright, here we are back together. Power cord running out where it was originally, and there's really no danger of the cord getting harmed by these tubes because they really don't get that hot. This is a very low current drain set. I think the audio output stage is only good for something like 100 milliwatts, so you know. And I had to replace the feet. The original rubber feet had dry rotted and cracked and fell apart, but I had 4 new feet I could install, so I think this thing's about ready to go.
Books, hopefully, portions of our show.
Here we are back together.
LLC's no.
Now, one thing I'll clarify, if I haven't said it already, this radio is so old that the dial is not marked in the standard kilocycles designation like they are today and have been for the past 80-some odd years. This dial is marked from 0 to 100.
And how you can fight back. Dennis Prager and Adam Carolla, they reveal how America has people on the left like Van Jones, Cornel West.
Yeah, Black Gospel Station seems to be experiencing some technical difficulties. Just changed formats within the past month or so and already having problems. Now also keep in mind this set has no AVC or nothing like that, so turned wide open. Let's see if we can get anything from out of town. I doubt it this time of day. Well, there's 670 just barely coming in, so we'll pick that up. We're doing good.
Throw them in the washer or dryer, whatever you want. I'm getting my...
And now 1390 is starting to appear. There's 1450, but 1390 is pretty much overpowering it. And you can still hear 1390 all the way up to the top of the dial. But like I've already said, these types of radios are not very selective at all, and if you have a strong, highly modulated station, it's pretty much going to blow the weaker ones that are adjacent to it out of the water. And another clarification, that cardboard doesn't actually prevent the chassis from coming in contact with the cabinet, but it does prevent the tuning condenser, which is directly connected to one side of the line and insulated from the chassis by rubber grommets. It prevents the tuning condenser from touching the cabinet, but the chassis is elevated from circuit ground by a 0.05 microfarad capacitor, and so it's still possible to get a tingle if you touch this metal cabinet while part of your body is in contact with something with a return path to ground. But yeah, I think this one's about finished.
I like Gallagher. God bless America and keep fighting the good fight.
Okay, I'm outside with the antenna just laying on the ground down here, and on these types of radios, like I've mentioned before, antenna is everything. If you have a good long wire antenna outside, that'll be a plus. Right now we're picking up 670. That's a little weak Black Gospel Station, about 30 miles away, so if it'll pick up that, it's doing pretty good.
I'm truly humbled to have this opportunity to share my journey with you. My hope is that as I grow, you are inspired and motivated. We do.
Even people on the left like Van Jones. Can't have a lot of fans. And I asked Barkley, I said, can you imagine
1450, but
NBA? Put your
1390's bleeding over on it.
Without fans. I think it's impossible to play without.
And that's a product of these types of radios not being very selective, and 1390 being exceptionally hot, if you will.
With available all-wheel drive and...
Okay, I was getting ready to end this video and put all the clips together and put it up there for your pleasure and enjoyment. But I discovered that for some reason one segment of clips got corrupted. I don't know whether it was the camera, I don't know whether it was the computer. Both of them are old and worn out and probably need to be replaced. So I'll just have to go ahead and describe to you the section that we missed. I ended up having to replace this volume control pot. I took the original apart. It was supposed to be 200 k ohms. It was reading over 1 meg. And I took the original apart, finally got it apart, cleaned it up, and it was actually worse after I cleaned it than it was before I started. It then had dead spots and high spots and things we didn't want, and then the off-on switch failed again. So I dug through my junk and I found a 500 k ohm pot that was very close to what came out of it. The shaft was a little bit shorter than the original, but fortunately we were still able to install the knob, and we were able to use that pot, and it works pretty good now. You still have to turn it about 3/4 of the way up at least before you get any audio.
And 90% of them.
And from my experience with these types of sets, that's pretty much the way it is with all of them.
Somewhere in the world,
the only way you're going to get by with a lower setting is if you live right under a 50,000 watt blowtorch, which I don't. So I don't know what was causing my files to get corrupted. When I tried to import them to Windows Movie Maker, it said the proper codec was not installed on my computer to play those files back. And then whenever I tried to play the files back manually through Windows Media Players, I got the same thing, and it showed there was 0 bytes of information stored for that particular file. So I don't know what happened. Hopefully it was just a fluke and it won't happen again, but you know, if it's like anything else with a computer, it'll only get worse. I may be forced just to buy a new one before long. But there you go, we're going to end it here, and I hope there's no more issues.